Hi everyone, welcome to this walkthrough of Edexcel A-Level Mathematics Mechanics paper, that is paper 32 of June 2019. This paper contains 5 questions and is set for a total of 50 marks. Before we start the walkthrough, let us discuss some common pitfalls that make students lose marks in the A-Level exam and how to avoid them. In mechanics exams, many a time, students lose marks by not sticking to the degree of accuracy as required in the question. If the question specifies answer to 3 significant figures, please stick to that. You can also draw a clue from the numbers given in the question. Unless specified otherwise, follow the same degree of accuracy as that of the numbers given in the question. Students also lose marks by mixing up the directions in SUVAT equation questions. If an object is projected upwards with velocity being taken as positive, then you need to take the acceleration due to gravity as negative. In connected particles questions, you can only take the whole as one system if the direction of motion is in one direction. This is not the case in police questions, remember, where something goes up while something else comes down. So in such cases, treat the objects separately and write equations of motion for each of them. Not doing so is another common mistake for losing marks in the exam. Another very common mistake is in calculating frictional force when the object is in limiting equilibrium and when it is at rest. The limiting equilibrium situation is applicable when the object is on the verge of starting to move, and hence you should write it as F equals mu times R. If it is at rest and not in limiting equilibrium, then the frictional force can only be equal to or less than the resultant driving force working in the opposite direction. When you work on varying acceleration questions, you should not forget to put the constant of integration c after you integrate. Hence, remember to capture the constant c, then proceed to find its value using the information which is almost always given in the question. We will have more top tips in the future walkthroughs. Now let us go to the questions. Question 1. In this question, position vectors are given related to a fixed origin O. At time t seconds where t is greater than or equal to 0, a particle p moves so that its velocity v meters per second is given by v equals 6ti minus 5t to the power of 3 over 2j. When t equals 0, the position vector of p is minus 20i plus 20j meters. Find the acceleration of p when t equals 4. Here, v is a function in t, and therefore to find the acceleration we have to differentiate v with respect to t. And after that, we will put t is equal to 4 to find the acceleration at t is equal to 4. So let's write v equals 6ti minus 5t to the power of 3 over 2j. Then let's write a is equal to dv by dt. So let's differentiate this. dv upon dt is equal to 6i minus 3 over 2 5 t to the power of half j. Simplifying, we get 6i minus 15 over 2 t to the power of half j. Now at t is equal to 4, a equals 6i minus 15 over 2, 4 to the power of half j. That's equal to 6i minus, this is 15 times 2, 30 divided by 2 is 15. So 15j, then we can write it as meters per second square because it's acceleration. Part B. Find the position vector of p when t equals 4. Again, position vector or r is given by integrating the v function with respect to t. So let's write this is equal to integral of 6ti minus 5t to the power of 3 over 2j with respect to t. That gives us 6t square over 2I minus 5t to the power of 5 over 2 times 2 over 5 plus c. So there will be a j here. Now, what information do we have to calculate c? The question tells us that when t is equal to 0, s is equal to minus 20i plus 20j, right? Let's put that back into this equation. Substituting, we get minus 20i plus 20j is equal to 0i minus this also 0j plus c. Therefore, c is equal to this value. Therefore, let's write the r function now, replacing the c. R is equal to 3t square I minus 2t to the power of 5 over 2 j. Then the c function is 20i plus 20j. Collecting the terms together, so 3t square I minus 20i, then we have got minus 2t to the power of 5 over 2j plus another 20j. Putting t is equal to 4, we get r is equal to 16 times 3, 48i minus 20i minus 4 to the power of 5 over 2 is 4 square rooted is 2, 2 to the power of 5 is 32, 32 times 2 is 64j plus another 20j, and then netting this off, we have got 28i minus 44j is the position vector m. So that's it. Question 2. A particle P moves with constant acceleration 2I minus 3j meters per second square. At time t is equal to 0, the particle is at a point A and is moving with velocity minus I plus 4j meters per second. At time t is equal to capital T seconds, P is moving in the direction of vector 3I minus 4j. Find the value of t. So to understand this question, let us take this as the initial velocity u and this as acceleration, and time is capital T here, and this must be the final velocity, but it is not actually the final velocity. It is in the direction of vector 3i minus 4j, means the final velocity is parallel to this vector. Therefore, we can say the final velocity v should be equal to some constant times 3i minus 4j. Putting them all into an equation, let's first of all write v is equal to u plus at, and in this context v is lambda 3i minus 4j should be equal to u, which is minus I plus 4j plus at. A is 2i minus 3j times capital T. Now let's compare the coefficients of I and the j on both sides of this equation. So there are 3 lambda lots of I here, so we can write 3 lambda I on the left hand side should be equal to minus 1i and then plus 2ti, and this implies 3 lambda should be equal to minus 1 plus 2t. Let's call this equation as 1. And second one, to take the coefficient of j, we have minus 4 lambda j should be equal to, on the other side, 4j minus 3tj. And this also implies, if I take out the j from each of these terms, I have got minus 4 lambda is equal to 4 minus 3t. Let's call this as equation 2. If we solve these two equations as simultaneous equations, then we should be able to solve for t. Since we want to get t, let's eliminate the lambda. That means let's multiply the first equation by 4 and the second equation by 3. Okay, so that is 12 lambda is equal to minus 4 plus 8t minus 12 lambda equals 12 minus 9t. Adding these two together, we have 0 here is equal to 8 minus 1t. That means 8 is equal to t. So the answer for the first part is t is equal to 8 seconds. Part B. At time t is equal to 4 seconds, P is at the point B. Find the distance AB. Let's find the position vector using the SWAT equation. So part B, we can write the equation S is equal to ut plus half at square. Substituting the values here, S equals U is minus I plus 4j, t is 4 seconds, plus half, A is 2I minus 3j, t is 4 again, square. That S is equal to minus 4I plus 16j plus 16 times 2, 32, divided by 2 is 16I, minus 16 times 3 is 48, divided by 2 is 24j. And simplifying this, we get S equal to minus 4I plus 16I plus 16j minus 24j, that's equal to plus 12I minus 8j meters. But the question wants us to find the distance. Distance is equal to the modulus of the displacement. That is equal to square root of 12 square plus minus 8 square, which is equal to 144 add 64 square rooted, which is equal to square root of 208, and that's equal to 4 root 310 meters. Question 3. Two blocks A and B of masses 2m and 3m respectively are attached to the ends of a light string. Initially, A is held at rest on a fixed rough plane. The plane is inclined at an angle alpha to the horizontal ground, where tan alpha equals 5/12. The string passes over a small smooth pulley P fixed at the top of the plane. The part of the string from A to P is parallel to the line of the greatest slope of the plane. Block B hangs freely below P as shown in figure 1. The coefficient of friction between A and the plane is 2/3. The blocks are released from rest with the string tight and A moves up the plane. The tension in the string immediately after the blocks are released is capital T. The blocks are modeled as particles and the string is modeled as being inextensible. Show that T equals 12 mg/5. I have captured here the diagram given in the question so that it will appear alongside our answer and it will help us solve the question more efficiently. The forces acting on the blocks are 3 mg, the weight of block B acting downwards, 2 mg is the weight of block A acting downwards again, and 2 mg cos alpha is the force acting on block A perpendicular to the plane, as well as 2 mg sin alpha, which is the force pulling block A down the inclined plane. There is also the frictional force F here. The question also gives us tan alpha is equal to 5/12. From this, we can easily figure out what sin alpha and cos alpha by drawing a right angle triangle. Let's call this as angle alpha here. This is 90 degrees. Now, if tan alpha is 5/12, that means opposite side over adjacent side is 5 over 12, which means the hypotenuse should be 13. Therefore, sine alpha should be equal to 5 over 13 and cos alpha is equal to 12 over 13. This will come handy for us in our further calculations in this question. Now remember that in questions where forces are acting on either side of a pulley, those forces will not be acting in the same direction. They will be acting in different directions. Therefore, we can't take the whole thing as one system and write the equations of motion. We need to write equations of motion for block B and block A separately. Here the task for us in part A is finding out tension is equal to what. So let's do one thing. Let's write the equation for block B. For B, 3 mg is acting downwards, is overcoming the tension which is upwards. Therefore, we could write 3 mg take away tension is equal to ma, that is 3m times the acceleration. We are following F is equal to ma here. Right, and then for A, the tension is pulling the block A upwards. Therefore, it's T minus, what are the forces countering it? There is a frictional force indeed, minus this 2 mg sine alpha is equal to its mass, which is 2m times A. Let us call these equations as equation 1 and equation 2. We also know that frictional force is equal to mu times r. Therefore, mu is given in the question as 2/3 times r is equal to 2 mg cos alpha. Therefore, the two equations can be rewritten now as 3 mg take away T is equal to 3 ma, and the second one T minus 2 mg sine alpha minus the frictional force becomes 4 mg cos alpha over 3 is equal to 2 times ma. We also know that sine alpha is equal to 5 over 13 and cos alpha equals 12 over 13. Putting this into this equation number 2, we get T take away 2 mg times 5 over 13 minus 4 over 3 mg times 12 over 13 equals 2 ma. Now we are after, this is equation 2 now, we are after the value of T. Therefore, if we try to eliminate A from these two simultaneous equations, we will be able to get the value of T. So let's multiply equation 1 by 2 and equation 2 by 3. So equation 1 multiplied by 2 equals 6 mg minus 2t equals 6 ma, and equation 2 by 3 we get 3t minus 6 mg times 5 over 13 minus 12 over 3 mg times 12 over 13 is equal to 6 ma. Now comparing these two equations, taking one away from the other, we get 6 mg minus 2t minus 3t plus 6 mg times 5 over 13 plus 12 over 3 mg times 12 over 13 is equal to 0. That is minus 5 lots of t plus 6 mg plus, this is 6 mg times 5 over 13, which is 30 over 13 mg plus 144 over 39 mg equals 0. Simplifying this, we get minus 5t add 234 mg over 39 to make all the denominators the same, plus 90 mg over 39 plus 144 mg over 39 equals 0. Therefore, 468 mg over 39 is equal to 5t. That leads to t equals 468 over 39 times 1 over 5 mg, and that is equal to 12 mg over 5 as required in the question. Part B. After B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. Determine whether A will remain at rest, carefully justifying your answer. After B reaches the ground, there will not be any pulling power from B, and therefore the only forces that will be acting on block A are its own weight trying to pull it down the slope, which is 2 mg sine alpha, and the friction will be working opposite to it now. So we need to consider both these forces and check which one is greater. If the pulling force down is greater, then the block A will start sliding down. If frictional force is greater, then it will be sufficient to counteract the weight pulling it down. So it will remain there. So let's figure out. After B reaches ground, the forces acting on A are two mg sine alpha, and the other one will be the frictional force will be 2 mg cos alpha multiplied by the mu value. So this is frictional force and this is the force driving it down. Let's say force pulling down. That is 2 mg times 5 over 13 and 2 mg times 12 over 13 times 2 over 3. Now let's figure out which one is greater here. This is 10 over 13 mg, 48 over 39 mg. Making the same denominators on both sides to compare. So it's 10 over 13 mg compared with, divide this by 3. So 16 over 13 mg. As 16 over 13 mg is greater, that is the frictional force is greater, block A will not move. So we could say as frictional force is greater, block A will remain at rest. Part C. Suggest 2 refinements to the model that would make it more realistic. At the end of every model-related question, you can expect a part question like this, wherein you will be required to make a comment on the validity of the model or make some suggestions for the improvement of the model. In this model, we were told that the blocks A and B were considered as particles. So we could suggest that we can allow dimensions for these blocks and consider them as 3D shapes instead of as particles. Another suggestion to improve the model could be to consider friction at the pulley or the mass of the string instead of considering it as light string. So we could say the blocks could be considered as having dimensions instead of as particles. Consider mass of the string friction at the pulleys. We only need two of them, so you can consider which one you are going to write. Question 4. A ramp AB of length 8 meters and mass 20 kg rests in equilibrium with the end A on rough horizontal ground. The ramp rests on a smooth solid cylindrical drum which is partly under the ground. The drum is fixed with its axis at the same horizontal level as A. The point of contact between the ramp and the drum is C, where AC equal to 5 meters as shown in the figure 2. The ramp is resting in a vertical plane which is perpendicular to the axis of the drum at an angle theta to the horizontal, where tan theta equals 7/24. The ramp is modeled as a uniform rod. Explain why the reaction from the drum on the ramp at C acts in a direction which is perpendicular to the ramp. The question requires a little bit of comprehension of the long worded sentences before we start answering the question. So the question tells us that the ramp is resting on this drum, and the key point here is the drum is smooth and is not having any friction. Therefore, the ramp should be able to rest at an angle of 90 degrees to the drum. Hence we can say that they will be acting at 90 degrees to each other, right? So we can say the drum is smooth, means there is no friction. Hence, the ramp will lie as a tangent to it. As the radius of the drum is at 90 degrees to the tangent, the reaction will be perpendicular to the ramp. I have captured the diagram once again here. There are two reactions involved here, one at point A, which will be perpendicular to the horizontal because there is a friction which is acting in this direction. Therefore, the reaction here will be perpendicular to the frictional force. The reaction at C we already discussed in part A. Because it's a smooth drum, therefore it will be perpendicular to the plane of the ramp. So let's call this as R1 and this as R2. The ramp is considered as a uniform one, therefore its weight will be working directly downwards from its middle. The midpoint is 4 meters here, 5 plus 3, 8 divided by 2, and then its mass is 20, hence its weight should be 20 g. Let's label this as 4 meters here. Okay, the question tells us that tan theta is equal to 7/24. Therefore, drawing a right angle triangle and classifying this as theta, this should be 7 and this should be 24. Hence the hypotenuse should be square root of 7 square plus 24 square, which comes as 25. Hence sin theta is equal to 7 over 25 and cos theta equals 24 over 25. The question asks us to find the magnitude of the resultant force acting on the ramp at A. Resolving forces vertically, this R1 and a vertical component of this R2 will be equal to this 20g. Suppose there is a vertical component here, that plus this R1 should be equal to 20g. What will be this component? Since this is theta, since this angle is theta, this angle also will be theta, because this and this are parallel and this are alternate angles. Consider this as a 90-degree angle here now. We want this particular reaction force which is going up directly. Now this angle is 90, hence this angle should be 90 minus theta. Hence this also should be theta. Hence this should be, this reaction force here will be R2 cos theta. Hence we can say, resolving vertically, R1 plus R2 cos theta should be equal to this 20g acting downwards from here. That is R1 plus R2 times 24 over 25 is equal to 20g. Unfortunately, we do not know R1 and R2. Therefore, we have to resort to another equation to solve this. Let's call this as equation 1. Let's take moments about A. The clockwise moment about A by this 20g force will be 20g times the perpendicular distance, this one, which is equal to 4 cos theta. So the clockwise is going to be 20g times the perpendicular distance 4 cos theta. Okay. Looking for the anti-clockwise moment, let's go back to the diagram. So anti-clockwise about A is this R2 multiplied by the perpendicular distance 5 meters. So it is 5 R2. And now, since it is at equilibrium, the moments should be equal. Therefore, 80g cos theta should be equal to 5 times R2. Also, we know cos theta is equal to 24 over 25. Substituting that here, we get 80g, 80 times 9.8 times 24 over 25 equals 5 times R2. That simplifies to, dividing both sides by 5, we get 16 9.8 times 24 over 25 equals R2. And putting that into the calculator, we get 150.53. But from the earlier equation, we know that R1 plus R2 cos theta equals 20g. That means R1 plus C. So 150.53 times cos theta again 24 over 25 equals 20 times 9.8. From this we can solve for R1. So R1 is equal to 20 times 9.8, take away 150.53 times 24 over 25. Putting that into the calculator, we get 51.49 newtons. We still have a little more work to do because the question is asking for the magnitude of the resultant force at A. So at A, what are the forces? So this is A. Okay. There is this reaction force R1, which we just now calculated, and there is a frictional force which is acting this side, which will prevent this ramp from slipping away. Therefore, resultant of all the forces at A will be the combination of this frictional force as well as this R1 acting at 90 degrees to each other. So we can use Pythagoras to find out the resultant force of that. So for that, we need to first of all find the frictional force. The frictional force which is acting this side will be equal to the force acting the other way around caused by the reaction force R2 at C. Therefore, we can say that, suppose I draw a right angle triangle here, then this will be R2 cos 90 minus theta. So we can say F is equal to R2 cos 90 take away theta. We can also write here resolving forces horizontally. Right. Now, what is 90? We don't know theta here. Therefore, it's better to convert this into some expression which is known to us. Let's say this is theta. Okay. And this is R2. And if this angle is theta, and if this is 90 degrees, then this angle has to be 90 minus theta, right? Okay. Therefore, cos 90 minus theta will be the adjacent side, this one, divided by R2. That same side will be opposite to this theta. So we can say cos 90 minus theta is also equal to sin theta. Therefore, we could rewrite this frictional force equal to R2. Instead of cos 90 minus theta, I can write sin theta. That is equal to, what was R2? 150.53 times sin theta was 7 over 25. Putting that into calculator, we get 42.15 newtons. Right. Now, let's proceed to find out the magnitude of the resultant force. So this frictional force is 42.15. This R1 is equal to 51.49. Therefore, magnitude of resultant force at A equals square root of 51.49 square add 42.15 square. So putting this into the calculator, we get 66.54, but to three significant figures, 66.5 newtons. Next part of the question. The ramp is still in equilibrium in the position shown in figure 2, but the ramp is not now modeled as being uniform. Given that the center of the mass of the ramp is assumed to be closer to A than to B, state how this would affect the magnitude of the normal reaction between the ramp and the drum at C. From the diagram, you can see that if the center of gravity moves closer to A, then this distance of 4 meters will decrease. It might become 3.5 meters or 3 meters. And in that case, what will happen is, if you look at this equation here, 20g times 4 cos theta is the one which is connecting to the reaction force at C. See, 80g times cos theta is equal to 5R2. And now this 80g comes from 20 times 4, right? If 4 decreases, that means the left hand side will decrease here. Therefore, the right hand side also should decrease. Therefore, we can come to the conclusion that if the center of gravity moves towards A, then the normal reaction at C will decrease. Question C. As center of gravity moves closer to A, the normal reaction at C will decrease. It's only a 1 mark question, so we don't need to do any calculations there. That's it. Suppose the question also asked you about the new reaction force R1 at A when the center of gravity moves towards A. Then what will be right? You can see from this equation that R1 plus R2 cos theta remains a constant 20g because the weight of this ramp is not going to change if the center of gravity moves here. It's still going to be 20g. Hence, if R2 decreases, this vertical component of that reaction force, that is R2 cos theta, will also decrease. And you know that R1 plus the other vertical component R2 cos theta should totally balance this 20g because this ramp has to be in equilibrium. Therefore, all total upward forces equals total downward forces. If R2 cos theta decreases, then R1 has to now support more of that excess impact. Therefore, R1 has to increase. Question 5. The points A and B lie 50 meters apart on a horizontal ground. At time t equals 0, two small balls P and Q are projected in the vertical plane containing AB. Ball P is projected from A with speed 20 meters per second at 30 degrees to AB. And ball Q is projected from B with a speed u meters per second at angle theta to BA as shown in figure. At time t is equal to 2 seconds, P and Q collide. Until they collide, the balls are modeled as particles moving freely under gravity. Question. Find the velocity of P at the instant before it collides with Q. So let us focus on ball P. Ball P has been projected from point A with a speed of 20 meters per second at 30 degrees to AB. Therefore, we need to split this speed into vertical and horizontal components of the initial velocity. After that, we will find the velocity after 2 seconds, which is the time it takes to collide with Q. And then we need to make it back into a total velocity by using the Pythagoras theorem. So if you want to write the hint here, not for writing in the exam, this is just for your revision, find the vertical and horizontal components of initial velocity of ball P. Then find those velocity components at time t is equal to 2 seconds. Then find the resultant vector. Find the resultant velocity. Okay, so what is the vertical velocity component here? So in order to make it clear, let me sketch this diagram quickly here. So this is 30 degrees, this is point A, and this is ball P. It's going up at an angle at 20 meters per second speed. Right, and therefore it has got a horizontal component here and a vertical component here. This horizontal component will be, and the vertical component will be uy. Okay, horizontal component of this will be 20 cos 30, and vertical component of this velocity will be 20 sin 30. Now we need to figure out these velocities after 2 seconds. Let's call them as Vx and Vy. Okay, so Vx will be equal to ux plus acceleration times time taken. Vy will be to uy plus acceleration times time taken. Now substituting these values, Vx after time 2 seconds will be equal to ux, which is 20 cos 30, plus we know that the horizontal acceleration after the projection is 0, therefore this is 0, and Vy is equal to uy, which is 20 sin 30, plus there is acceleration here. Since it is projected upwards, the acceleration due to gravity must be minus 9.8, and the time is 2 seconds. So that is equal to 20 times cos 30 is root 3 over 2, and Vy is equal to sin 30 is half, therefore this is 10 minus 19.6. Simplifying this, this is equal to 10 root 3, underline this, and this is equal to minus 9.6. Therefore, velocity at 2 seconds is equal to square root of 10 root 3 square plus 9.6 square. Putting into the calculator, we get 19.8 meters per second. So this velocity is the resultant velocity at 2 seconds. Part B. Find the size of angle theta and BII, the value of u. So theta is the angle at which Q is projected, and value of u is the velocity of Q at the time of projection. There are two unknowns here, theta as well as the u. Therefore, we may need two equations to solve them. So what all information do we have? When these two balls collide with each other, the total distance traveled by them, that is sum of the distance traveled by P and the sum of the horizontal distance traveled by Q, horizontal, okay? That must be 50 meters, right? Okay, this is 50 meters. So we can develop an equation for that. Next is the vertical distance traveled by P and the vertical distance traveled by Q should be equal, because otherwise they can't collide. Okay, these two bits of information can help us in developing two sets of equations. Let's write that. So we can write when P and Q collide, okay, sum of horizontal distances traveled, sum of horizontal distances traveled by P and Q should be equal to 50 meters. Then the vertical distance traveled by P is equal to vertical distance traveled by Q. Let's use this formula for constant acceleration. S is equal to ut plus half at square. Okay, so for P, this is going to be 20 cos 30, that is u, times the t, which is 2 seconds, plus half, acceleration is 0, times 2 square is 4, and that is equal to 40 times root 3 over 2 plus 0, okay, which is equal to what? 20 root 3. And that is the distance. Therefore, let's write meters. And for Q, the same thing would be, we do not know the velocity, therefore, the initial velocity being u, let's put it as u cos theta times 2, because it is ut, okay, plus half at square. Again, it's going to be half 0 times 4 is equal to 2u cos theta. Therefore, as per our equation, these two distances should be equal to 50 meters. So we can say, therefore, 20 root 3 plus 2u cos theta is equal to 50 meters. Therefore, u cos theta, this one alone, is equal to 50, take away 20 root 3 divided by 2, and which gives us 25 minus 10 root 3. Let's park it there. That is, the left hand side is u cos theta. Let's write that, otherwise we'll forget what this is. Likewise, let's write the vertical distances traveled. Let's call this as sy. That is also equal to uyt plus half at square, right? Therefore, in the case of P, it's going to be 20 sine 30, that is u, times t is 2 seconds, plus half, bracket minus 9.8 times 2 square, okay, and that should be equal to u sine theta, because we do not know u as well as theta, times 2 plus half, here also it is minus 9.8 times 4. Removing the equal terms from both sides, we get 40 sine 30 equals 2u sine theta, which simplifies to 20 sine 30 equals u sine theta. Again, sine theta is equal to half, therefore this is 10 is equal to u sine theta. Therefore, we have got two equations, one containing cos theta and the other containing sine theta. So let's try making it as tan. So dividing equation 2 by equation 1, we get 10 over 25 minus 10 root 3 should be equal to u sine theta over u cos theta, which translates to tan theta. Therefore, 1.30 is equal to tan theta, leading to theta is equal to arc tan 1.30. That gives 52.48 degrees. Park it there. So we got theta. Now we need to find out u. We can use equation number 2 to figure out u from here. So we can say from equation 2, 10 is equal to u sine 52.48 degrees. Therefore, u is equal to 10 over sine 52.48, and that gives us 12.6 meters per second. Part C. State one limitation of the model other than air resistance that could affect the accuracy of your answers. The safest comment that we can make here is the balls have been considered as particles, whereas they will be having size and shape. So we could say the model could consider the size and shape of the balls instead of treating them as particles. That's it. That's the end of this question paper. Hope you thoroughly enjoyed this walkthrough. Thank you very much for being with me. Let's meet again in the next walkthrough. Until then, goodbye.